Okay, in this video, I'm working through the 5.2. Last time I did 5.2 and examples were solved, but in this video, I'm going to walk through 5.2, the exercise. So start beginning, let me not waste time. I'll begin with exercise. The very first question, yet again, another example which we did in the class. How do you identify which among these is exponential model? And if it is yes, is it growth, exponential growth, or is it exponential decay now? If you look at this, the first one, I can see this is, uh, so you have 10x squared where you have this piece is a variable raised to a number. So that's, that's called also power function. But the power function, when especially if the number is a positive integer, like in this case, it is x squared, where it's a polynomial and it is polynomial of degree is 2, and degree is 2 is quadratic. So that's quadratic equation or quadratic function. So the shape of this, if you put on the calculator, you'll see it's a graph like this. The second one, yes, the second is y equals. So here, 9 raised to x. This itself is like a number raised to a variable. So whenever you have a number raised to it, and we want to make sure this is positive. So 9, this 9, when you compare to y equals exponential equation is this, you can see the b that you have is 9, which is, it is not 1 and it is greater than 0. As long as you have this, that's good. So this is exponent. Yes, this is exponential model. And you can see it is plus here. If you want to graph, starts at 298, maybe this is 298, and the graph will look like this. The next one is linear model because the degree is 1, and you can see there the slope is -3. When you compare to y equals mx plus b form, that's called the linear model, so, which is negative. So negative basically means on the, if you draw x-axis and the y-axis is going to be a line going through 10. So if you have to do like this, so somewhere here 10, and a line is going this way, -3 over 1. It means for every one run, if you run one run, you drop down 3 like this. So you would go one run, you go 3 down. So that's how, so this is not exponential model. What about the next one? Yes. And you can see this piece is, yes, it is exponential model. I don't want to take too much time. You already understand. The main thing is the b is a fraction. It is in decimal 0.0, which is this number that you have is less than 1. So whenever 0 less than b, if b is between this, then we call this as exponential decay here. So this is exponential decay equation, and there is a decay factor. The number itself is called a decay factor. The whole thing is there is an exponential decay. It means the graph maybe starts at 98. Let's put this at 98 because of this, and then the graph decays like this. And the last one is this piece. Again, you have a is 15 when you compare to the exponential exponential function b raised to x. I call it the exponential function, exponential function. Now, function means we use the letter use f. It means instead of y, you call it, you use f of x. It means the y depends on what value, what value of x do you put in. So that's why we say this is, instead of y, you could also write f of x. So we call, if you write this, we say it is exponential function. But if you only write y equals, you can call it equation also because there is equal sign. See this part? Okay. Now, So this is exponential function or equation, and the b here is 5 over 3. And you can see 5 over 3, this number 5 is, the numerator is bigger than the denominator, and therefore this is greater than 1. Because when you say 5 over 3 is 1 2/3, you can see this when you write in the mixed fraction, or it is also 1.666666 like that. So this is this is called growth factor. Okay, so that means there is a growth. That means if we draw x-axis y, so this is where it starts. The initial point a equals 15. And this is when 0 is 15. So if I take 5, 10, and 15 here, and then the graph will look like, even though this is 1.66, almost like closer to 1.5. So it starts here and the graph goes something like this. Okay, let's move to the next question. Like, okay, the second question says, give an exponential model of the form this. How do we determine if it has exponential growth? And this is the same thing. We have y equals a times b raised to. So how do we know it has an exponential growth? You want to make sure growth is when this b has to be greater than 1. And one example is, at the same time b is greater than 1, okay, so an example could be 2 into 3 raised to x. See? So this 3 is greater than 1. And another example I can give is 2 is times 1 3/4. See? This is b is 3/4, and 3/4 is less than 3/4 is less than 1. So when b is 3/4, there is a exponential decay. So hope that helps. And at the same time, you also have to make sure that a is positive. So this has to be positive, and then you can decide b greater than 1 and all that. But if it is a is less than 1, let's see if I put -3, and then for the growth, this has to be fraction, like maybe 1/5. So that will be also will be growth, even though this looks like a fraction, but there is a minus here. So what this minus does is the actual graph of this is this way, but because of minus, the graph reflects over the x-axis. So that's why you have to, it depends on, so this will be like growth. See, it is, even though this minus makes it growth. So that's how the understanding. Let's move to the next question. So the next question number 3 is, determine if each of the scenario can be modeled with an exponential equation. So can we model this with this equation? Now, if you see the first equation here, the tuition fee increases by 2 each year per credit. Now this means it's the same amount of money increases. This is not exponential. This is not exponential. It means it is like y equals m of x plus b. It means maybe in the beginning this was what was the tuition per credit in the beginning, but then every every year it increases by $2. So it is like 2x and plus what was before. They did not give us that information. So this is not an exponential. What about the next one? Tuition fee increases by 1% each per credit. Yes, now here there is a percent increase. So this is percent increase is R, which is 1%, and 1% basically means 1 out of 100, which is 0.01. So there is a growth factor here. B is So it is 1 plus that R, and B becomes 1 plus 0.01, which is 1.01. So when you create a exponential model, this will be what was in the beginning, we don't know. Whatever that A is, this is that A. And then every year it grows by 1%. That means the B is 1.01. And the T stands for the how many years since what was initially the whichever the year the initially the credit how many dollars per credit. So this is yes, it is exponential. The next one, C, the value of a car depreciates 15% annually over last 10 years. So that means it's like I just wanted to show how in the beginning, maybe there is there will be some amount here, maybe $40,000 car, right? So this is years, T stands for number of years. So T could be number of years since the car was being bought. And this is the value of the car. So this is like X and Y. You can use X and Y, or you can use, uh, instead of X and Y, you could use T and number of years since you bought the car, T and V for value of the car. Now this value of the car goes on depreciating like this, 3, 4, 5, 6, like that. 6, 6, 7, 8, and then 10, right? So how does it depreciate? It goes down. That means what is the decay multiplier we have to know. Now because it decreases by 15%, this one 15% basically means it is 15 divided by 100, which is 0.15. So that means uh, because it is decreased, the B, instead of B, you don't add, you subtract this percent. So this is that R percent decrease. So B is 1 minus 0.15. Little maths you take away, they do this, you get 0.85. See? So this is that important piece. That means in the beginning, let's see if it was 40,000. So the car in the beginning was 40,000. And then the exponential multiplier, I don't say growth, but that is exponential decay factor. So this decay factor is 0.85 and raised to how many years since you bought. This has become the exponential model for this one. Yes, this is a scenario can be modeled with an exponential. So not only that can be, we already modeled right here. If your original car cost 40,000, this is how it is. So at any moment we can figure out on the calculator. Let's see if we want to know after 15 years what will be the value. We can figure that out. Just putting on the calculator this part, this t equals 10, and get the answer. Then Uh, e- now, for each delivery stop, the driver increases the cost by $5. So every time each delivery is increases by 5, it means if X is number of deliveries, that means you're paying $5 to. This is like a down payment, whatever down in the beginning. So this is like Y equals 5X plus your initial charges, and how many times you deliver, that will be like a slope. This is like a slope. So this is a linear model. So because you are doing the same thing at each delivery, it's like slope rate of change. This is like that M is 5/1 for each delivery. So this is dollars, and the down is one delivery. For every delivery, you're paying $5. So this is no. So this is not cannot be modeled into exponential equation. The last one, population in the culture of bacteria doubles. So now what is the meaning of doubles means the multiplier here is already given to you 2. So your B is 2. And it goes for every 4 hours it doubles. So you have to be very careful here. Whatever the bacteria, suppose in the beginning the bacteria, let's put it like if the bacteria was, if there were 45 bacteria. Now what's happening is 1, 2, 3, and in every 4 hours, this is I can put H is or X is, which is number of hours, and this is the population of bacteria, P. So we can think of from 45 doubles to 90. So from 45, when you do 90, so there is a multiplier here, it doubles. So that's like it's not, I'll use this as B equals doubles 2. I do not use, this B is each hour. So this, when you talk about low, when you talk about this B in the formula Y equals A, this B stands for, this is each, for each increment of 1, each increment of X by 1. So it means it increased by 1. But right now, in this example, it is 4 here. So that means you have to see what is that. Uh, so from here to here, there are another multiplier, which is B. So B, that is the B lowercase. So that means B times B times B times B is this big one, that is 2, which is 2. And this is what we have to figure out. And I know right now you may get confused. It's okay. We'll talk about it later on. So you got B raised to 2 is 2. And how do we solve this? So this by definition, if you have this, then B is 2 raised to 1/4 directly. And the formula is, if you see, so the formula is like this. If you have B raised to n equals, let's see, A, or we can better write A raised to m is B, then, A equals B raised to 1 over m. So this is the formula. Now the question is why? Because if I write 3 square is 9, we say, okay, this 3 is, we use the symbol square root of 9. This is the square root of 9. So this 3 is a square, and it is a positive square. So we write plus here. Positive. So what is the meaning of a square root? Means how many times, what number multiply itself to give 9? And you can say it is 3, because 3 times 3 is 9. So 3 times 3 is 9. So when we talk about, when you write like this 25, what does this basically mean? You're asking what number here. So we are just asking what number multiply itself to give 25. And the only way is this 5 times 5 is 25. Okay, you may say also, why not negative 5 times negative 5 is also 25 positive. Why not negative 5 here? No, because there is already plus here. So you have to take positive 5 here. Now, as and when we require this, we'll see. I don't want to. Let's go directly to the next question. So yes, this is correct. This is, we can model this by. So I was talking about, remember B raised to 4 was doubles means 2, and then I wrote B is 2 raised to 1/4. So basically, when you write the equation, I remember that problem. I gave 45 bacteria was there in the beginning, and now this piece goes as the factor, which is 2 raised to 1/4, and then goes the T outside is T here. So basically, the equation reduces to 45. You can write it also. What is 1/4? See this 2 raised to 1/4 of T. Now, laws of exponent says if you have A raised to n, this is A raised to m times n. So it means we can multiply 1/4 to T. So basically, this becomes 2 raised to T by 4. See? So that's how it is. So the whole equation reduces to, so this whole equation reduces to y equals 45 times 2 raised to T up divided by 4. See, that's how it is. And you're done. I hope I'm making sense here. And let's go to the question number 4. Find the formula for exponential equation. which passes through these 2 points. So you have given this point. So if you see, this is like 0, 1, 2, 3, 4, 5, 6. This is 0, 6. So there's 1 here. And then there's 3, 1, 2, and 3. It is 750. 750 is a big, 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 big number maybe here. So your graph is kind of, this is that 3 is 750. And there is a graph like this which goes. So we don't, no need of graph. I just want to get an idea of how the graph looks like. The equation is y is a raised times b raised to x. See? Now, what is this a basically means? It is like when a x is 0, it is a. Now, the good news is in this problem, we already have, even though we can write x1, y1, and this is x2, y2. Remember, you can plug in each. We did in, we could, this problem, if 0 was different and if this was a number, then we will do different method. Because now it is a 0, so we know the 6 itself is your a. So this a, in this example, your a is already 6. So the equation is y is 6 times, that's the initial number, times x. Now, our next goal is to figure out what is this x, right? So to find this, we'll use the second point. So the second point is x is 3 and this is the y. For I, this is the second point, x2, y2. So y is replaced by 750 and 6 times b raised to x. Then divide by 6, let's solve for x. So this 6 and 6 crosses out. If you do little maths here, you'll get 125 with the calculator, or you can always do mental maths, or if you want, you can do 750 divided by 6 like this also. Anyway, now you have b raised to x. B raised to x, and the value of x, I think I forgot to put. What is the value of x here? X is 3, so that's 3 goes right here. So b raised to 3. So now the moment you get this, the good news is in this example, let me wipe this. We don't need all this. Was the graph needed? No, I'm just showing this. You can fast forward. If you understand, you can fast forward this. I'm showing all the steps so that those who get confused maybe won't need help. Okay, so I'm gonna write this again. B raised to 3 is 120. So the common sense tells us what number that b, what is this multiplied 3 times to give 125? And the common sense, it has to be 5, 5, 5. Okay, so b is 5. So by directly it is b raised to 5. But how do we write algebraically? You write, they use, it's like raising both side. If it is 3, you raise both side by 1. If this is 3, you write 1 over 3 and here 1 over 3, see like this. So that this 3 and 3 crosses out because b raised to 3 and raised to 1 over 3, this is power of power. We write the first exponent multiply the second exponent, and this is over 1. It is b raised to 3 over 3, which is b, just a b, or just cross out, see? Or just cross out. And the calculator does the job. So if it was different from, we can go right here, put it in the calculator, see? So put it on. So you have this. If there is something on the screen, click second mode and clear anything. And then we'll use 5 raised to, right? So I put 5, open, put 125. So let me take off this, delete, and put 125, close it, and then go up. So you go up, and there's a fraction 1/3. So alpha, this, and enter, and put 1 divided by 3, and enter, you get the answer 5. So this is how you're going to use. But if you are using Desmos calculator, and this is what And you can use also, here it is, I showed you. So there you go and click on the scientific calculator. And you can use like this also. So open parenthesis 1 to 5, close it, then go up. So you can click on this one, so this piece, e raised to b. Click on this. And you can use directly also 1 divided by 5. So it works. And you get the answer. Sorry, one third, right? One third. Go backspace and put a 3, you get 5. So you can use both. So this is using the Desmos calculator, but I want you to guys use this TI-84 because we need these later classes. Let's move on to the next example. So the next example, I'll skip this because it is almost the same thing. Okay, so what I'm trying to say, the same thing means you have, the moment you have this itself is, your A is 2000, right? Okay, and then what all you do is, this is the X and Y. So your Y is 2000, you already got, time B raised to X, and you plug this Y here, this 20 goes here, this X goes here. So 20 equals 2000 times B is what we need to figure out, and this is 2, divide by 2000 both the sides, and you can see this 0 crosses out, and you are left with 2 over 200. You can still, this goes away, you get B square, and you can write 2 divides this, so that becomes 1 over 100, or if you want, you can use calculator, and you'll see it is 0.01 equals B. B square. So how do you find the B? So once you have this B square, let me write this. B square is 0.01, right? So what number multiplied itself to get 0? One thing is you can use your common sense. It has to be 0.1, 0.1, right? Or use the B equals, remember that the way how do we do, raised to the power. If this is 2, you just put 1 over 2, put this on the calculator, and you will end up getting 0.1. So this equation will then rewrite, or eventually the B is that what you got is 0.1, and you get X, and you're done. I'll put a parenthesis here. Question number 6. Now, look, you are given 2 points. In this case, we don't have, this is not 0, right? So if this is not 0, you use another method call it this as x1, call this is y1, call this is x2, and call this y2. So the first step would be, step 1, we'll try to get two equations. The main equation is exponential model is a into b raised to n. So step 1 is you plug in the first point, that is -1. So the y is this one. This is y. That goes 3 by 2. Okay, and then equals a we don't know, b we don't know, but we know x, and that is -1. So this is -1. So this becomes equation number 1. I'll call this as equation, let's see, 1. Now second time you plug in this y2. Now you're using this 24. So instead of y, you use 24 equals time b raised to, and x2 is 3. So that 3. So this becomes equation number. So what do you do? Next step is, we will do a step number 2 is divide. So divide equation 2 by equation 1. So what that basically means, this is 2, right? So I'm going to write this again. So this, the second equation is 24 equals a times b raised to 3. Now this one you're dividing by the equation 1. So you have to divide the number divided by the number. This is 3 by 2. That's get divided by here. And this part, this piece, you divide here. A little hard work there. Now you can use this equation, you can use keep change flip. That means if you have 24 and divide by 3 by 2, keep the numerator as it is. This is the numerator, this is the denominator. So keep the numerator, flip the division sign to multiplication. I mean, switch the, and flip this, which is reciprocal of 3 over 2 is 2 over 3. And you can see this is 1, 3 divides 24, 8, and 8 times 2 is 16. So this whole thing, the left part is going to be 16 equals this A and this A crosses out. Now you may get confused with what the heck is this, right? Let's do the scratch work. If you have B raised to 3 over B raised to minus 1, the exponential formulas, the laws of exponent says it's a quotient of power, B is in the up and down, so just write B, and this M3, and the minus 1 which you hear is changed to plus 1. So you get B raised to 4. So this is how this answer is going to be B raised to 4. So those of you who are confused, what the hell is this? So let me write the formula right there. As I said, as and when required, I'm going to show the formulas also. So that is, the formula is like this. If you have A, this is called product of power. Means if you have product and there are the power, this both are powers, these are exponents, or all you do write the base and then add the two exponents. But if you have a quotient of power, there is a division, you can see the base, both bases are the same. Write the base as it is, and then subtract the exponent. So this m and this n. So that's what I try to do here. In other words, this n we can write with minus here. So once you get this step, next step here is to figure out b. So b becomes, so this is b raised to 16, right? So then by definition, we can write b equals 16 raised to 1/4. This is what. So what did I do here? Is if you have a raised to m equals, let's see, a raised to n is b, like p, whatever that is. And a is p raised to 1 over n. So that's kind of a formula I'm using directly. Or the digital textbook will show you, you raise to the power 1/4 here and do 1/4 here also. So that also correct. So that way this crosses out and you ending up here. Now use the calculator, which I already showed you. 16 1/4, you get the answer is 2. So your B is 2. Okay. Now this equation now we'll put it like this. So that equation reduces to, let me clean all this. So a lot of work here. These are a little hard because there's too much of work to be shown. So this equation now will be y is a times the b is 2, right? So this b is 2 here. So 2 raised to x. Okay. Now our next goal is step 3. So what is the step 3? You have to plug in one of this point, this or this. I'm going to use this point because this does not have a fraction. So x and y, replace y is 24 over here. A and 2 raised to x is 3. Okay. So that way we get a times 8. 2 because 2 cube is 8. 2 cube is 2 times 2 times 2. This is 4 times 2 and 4 times 3 is 8. And then divide by 8 because you have to solve for a. And you can see this 8 crosses out and you get a equals 3 because 8 divides 24 3 times. And your final answer is whatever that you get here, you plug it here. Okay? So your final equation is y equals 3 times. You're done. Okay. So this is how you have to do this problem. Let's do another one. Question number 7. Find the exponential equation. That this time we have same problem but different situation. X2 and Y2. So step one is just plug the X and Y, right? So the main equation is Y equals A B raised to X. So if I plug in this, X was 6 equals, this becomes 6 equals A times B raised to minus 2, which is up. So that's equation number 1. And the second equation we can use is Y. This time we put Y. So it is like 1 equals A times B raised to 3. See? So you get 3. So now you have to divide this over this. That means you are using 1 equals, this is the second equation you write first, and both sides you divide by the first equation. That means this 6 will go down, and this piece will go down here. Okay? So on the left side is 1/6. We can cross out this A. We can bring this up here, right? B is 3 plus 2 by using the quotient of power formula. So this means it is B raised to 5 is 1/6. And then we can directly write B is 1/6 and raised to this 5 on the other side goes as 1/5. And that's what we put on the calculator. Remember, it is 1/6, 1/5, right? So 1/6, 1/5 is if we go to the calculator, I'll clear this first and put 1/6, 1/5, right? So 1 alpha this, 1 go down, go up, put 1, go down, put 6, right click, close it, go up, and then again you want fraction, enter, and 1/5. So 1 down, 5, there you go, you get 0.698827. So that part I'm going to use there. I'll go back to, so this is 0.698821. So because there is 6th place, so I'm using 6th place there. So now that equation, this will now reduce to y is, okay, step 1, this was step 2 by dividing, okay, and then because of this, we write, you got b, right? So I write a times b is 0.698821 raised to x. So our next goal is to find out the a parts. Yeah, we don't know what is a. So one of these points has to be plugged in, either this or this. I'll use this point, 3 and 1 is better. So in place of x and y, now you plug in this. That means it is 1 equals a times 0.698821 and raised to, there is a 3, see, this goes as 3. Now to find this a, don't do nothing here. What you do is divide both sides. So now I'm dividing by 0.698821 raised to 3, and also here 0.698821 raised to 3. So this crosses out. So eventually you get a equals this piece. So this is what we have to put in the calculator. So when you put in the calculator, So here is the calculator. I'll clear this. And you have open parenthesis. Because there is a fraction 1 over it, you can check back. So alpha this, you put 1, go down. This is 1, down. And open parenthesis, it was 0.6988, 0.698827. Yeah, correct. Correct. Close it, go up, put a 3. Okay. And enter, you get 2.93015. I can round this to, so if you can see this place, 6 places, the sixth place here, if you see there, the sixth place, it is 930,157. But after 7, there is 5. So this 7 can be rounded to 6 places. 7 becomes 8. So this number, I'm going to write it as, go back here. So your A, this A, so this is 0. Sorry, so it is 2.93015. It was 7, but I changed it to 8. So you got 8. Now all this you plug in here, your final. And step 4 is the conclusion. And the conclusion is y is 2.930158 times the other one is this, and you're done. I hope you guys got this. But then you may say, like sometime, like in this example, we got this is 3 and minus 2. What if this was, oh, so let me see, I'm gonna use this, okay? What if you have b raised to 5 divided by b raised to 9, maybe, see? In that case, you have to write down maybe 2 here, okay? Then you have to write b equals 5 minus 2, that's it. So you don't, because this is plus, so the changes to plus changes to minus 2. Okay. If it was minus 3 and let's see b raised to minus 7, then you will write b, this stays the same. What changes is this one to plus 7, so which is b raised to. Uh, if you see the next question there, I'm going to skip this. It is the same thing. Question number 8, I'll skip. Let's go directly to, okay, this also same thing. Let's try this because it has a big number there. So call this as x1, y1. Step 1, call this x1, y1, and call this x2, y2, and substitute the main. So your equation is y is a times b raised to x. So plug in x1, y1. So this will be this one, 2, 2, 2, equals a times b raised to 3. That's the first equation. The second equation is this is y2, that is 7, 7.4, and a times b raised to 10. Now you have to divide this to this one. So I'm gonna use the, so each of this divided by, so this black is divided by this here. This will be divided by 2, 2, 2, 6, 2, divided by this one, a times b raised to 3. And so this crosses out, okay, a crosses out, and there's a 10, and this is 3, so it will be subtract here. Now this whole thing, I'm gonna keep it as it is, or we can also use calculator to figure out what is that. I would just keep it as it is, because the next piece is Look, to get a perfect answer, keep this exactly the same. And this is b raised to 10 minus 3. So if you do 10 minus 3 is 7, and then you use b equals this whole thing, and this whole thing, because this is 7, you write 1 over 7. Now on the calculator, we have to put this. So go to the calculator, this one, clear this, and let's put the, first of all, open the parenthesis, then you do alpha this, enter, so you have a fraction. And remember the numerator was 77.456, go down and put 222.60, close it. Not this one, delete, go right click and close it. And then you go up, and then you again, sorry. If anything happens like this, click second mode. So you get back to that. Then go here, right click, and go until you go up there, and you want alpha this to get a fraction. Enter, and that should be 1, and divide by 3. See, and you get the answer. Yeah. Now see, I made a mistake that I put that 1/3. It should be 1/7. So you can go backspace like this, enter, and you have to edit. Go up. Sorry, go here. Right, left. Go left. Go left, and make it 7. And then right click, enter, and you get the answer. Can you remember 0.86 011? And this question says 2 places of decimal. If you see this. Uh, this has 2 place decimals. So the B that you get here now in the calculator, you can round it to 0.2 places, 8 and 6, and you're done. Now this goes in the equation right here, see? So the equation is y equals a times, now you got 0.86. Our next step is to find the A. A is our goal, right? So we will use one of these points here. The best way to uh, plug in here is, I think we'll plug in the first one. So let's plug in this as your xy. So the y is 62, so this is 62. A, we don't know, and x is 3. So now divide both, divide both sides by 0.86 raised to 3. Here also 0.86 raised to 3. And you can see this crosses out, and you get A equals, and now put on the calculator. So let's go back to the calculator. 62 divided by, oh God, I made a big blunder here. This y is 60, not 62. This is wrong. Y here is 222 points, so 222.62. Okay, so let's put this on the calculator. So here is the calculator, clear everything. So 222.62. So we put alpha this and put 222.63, go down and put open parenthesis 0.86, close it, go up and put a 3. Okay, and then you enter, get 350, right? So 350.01, 2 place decimal will be, if you see this, it is 350.016. But because we want 2 place decimal, I'll put 02. So go back to the thing, and you get 0, 350. 0.02. So this is your value. So eventually, this was our equation, right? And so now that equation changes to y equals 350.02 times raised to. So this is the final answer. And if you want to graph this on the Desmos or the calculator, you can do this. Uh, just wanted to show also, if you want to do, you can use desmos.com like this. And in the graph, open graphing calculator, and you can put y equals, there's a thing here, you can use this window to type in like 350.02 times, and then you have 0.86, 0.86, and close it, go up, put X. Okay, it looks like you can't even see the graph, right? So all you have to do is, because this 350 is a big number, so you have to change this window here. You can see that the y-axis minimum and the maximum. So instead of 5, there is a 350, so maybe I want to write 200, maybe 250, like this. Or I can make it maybe 400 to see more graph. And you can, we don't want too much of negative, maybe I want to put -2. And you can see how beautiful the R and the graph here. Or if you want, you can change this X to a bigger number, maybe 20. You can see more of the graph. See how nice it looks. You want to make it 30 also, 35. And you can see more beautiful exponential decay graph. Can you see this? Nice graph. That means this goes to this point, which is the y-intercept. And you can also put a table and put all the numbers, see, -2, -1, like this. You can put 3, 4, 5, 6, 7, 8, 9, and like that. See? You can 11, 12, 13, 14, 15. And that's how this number, they go on decreasing. See this one, click each one of them. These, the output goes on decreasing. So there's a common multiplier, which is 0.86. Hope that helps. If you want to use on the TI-84 also, you can do this. You'll have to click on y equal and put 350.02, then multiply with this, open parenthesis, and 0.86, close it. Oh, crap. I'll have to type again 350.02 times, open anything, parenthesis 0.86, close it. I think I messed up here. So I go backspace and put a 0. This one is 0. And then you need to go up. I think this should be point. And you go up and put a X. See? Put a X is this one. Now and then the graph. You see you can't even see the graph. So you have to do, there's a window we have to change here. Like last time I changed, I don't want too much negative, so I'll just put -2 maybe. And then I do maximum, go scroll down. I remember taking 35 or 40. I'll take 35. And then you go scroll down to changing the Y, minimum Y. This is minimum Y. I don't want too much down, so I'll just put -3. And I want more of up, so that will be like 400. 400. Okay. You can also change the scale also. What that scale means. This one I'll scale off maybe 4, and then the next one I can change maybe scale of 50 maybe or 40. So you will realize there's that many graph. So these are the some changes you do uh, so that you can see the whole graph properly. You can see how the graph looks like, beautiful graph. And if you see the y-intercept, you click on second calc and put value, enter value, put a 0, and you'll see get the answer 350 point that answer. See, so 350.02 like this. You can find anywhere. You can trace also instead of this. Let's escape. Mm, or instead of this, we can just trace here. See, or maybe what I wanted to show is just a trace. Let's see graph, then trace, and put any point you can put. Let's see 5. X is 5. You get the answer there. I hope that makes sense. Okay, so I'm showing two different ways. One is using the. You may get confused about this window thing, what I talk about. So I hope as in when you play around with this, you realize how beautiful it is. This. Okay. So let's go to the next. Okay, this is question number 11. 11 is a Mexican gray wolf was reintroduced in Arizona and New Mexico in the year 1998. So I'm just trying to make a visual understanding here, just to show that what is X and what is Y. So in the year 1998, so the authorities initially released 11 wolves. So that means 1990 is in the beginning. That means like a 0 year. So we say X when X is 0, that means 1998, there were 11 wolves. So this is 11, right? Then in the year 2012, that means this is 98, then 1999, 2000, 2001, 2002, like this. If you go on, then in the year 2012, so somewhere here, so that means we need to know how many years have passed since 2098 to 2012. So what is that? How many years have passed? So we need to know this piece. And you can see 2012 minus 1998. If you subtract, you get 4. So that means, you get 14. So that means this is 14. So when it is 14, the number of wolves were 58. Okay. So that means we have to create an equation y equals a times b raised to x, right? So by just looking at it, you can see this is 0. When x is 0, this itself is like a a. So the equation is clearly says this is 11. So 11 times b raised to x. So this point, the first point that is here, in the beginning there were 11, so this is taken care. Now we have to use this point, that is 14, when it is 14 years past since the wolves were introduced. This is the second point, that is like this is the x2, y2, like, and this point, the first one that we had was 0, was 11. See, this was that x1, y1. So we'll plug it in here, this piece. Now you're going to plug in this x and y. So this is like x and y only. So there is 58 is the y. So this is 58 equals 11 times b raised to x. X is 14. See, this x is 14. Now you have to solve for b. So divide by 11. So I'm going to divide by 11. So this crosses out. So this b raised to 4, I'm going to write first this one. So b raised to 4 equals 58 divided by 11. And then b equals. Now I want to get away with this 4. So how do you do that? You write 58 divided by 11 whole raised to 1 over 4. And that piece you have to put on the calculator. If you put this 58 over 11 and divide, 14, right? This is 14. This is 14. Put on the calculator. If you want, we can use Desmos calculator like this. So let me take a few Desmos so that we understand Desmos.com also. Many of you don't use, you do not have a TI-84, you can use this calculator. So we need to know, so click on this. click open parenthesis, and you have to have a fraction. So here we don't have to use directly. You could do 58 divide by 11, close it, go up. Uh, so I'll backspace here. You have to right click to go outside, and there you close it. And now you have to go up. So you click this one, and then when you go up, it is 1 divided by 14. So you can do 1 divided by 14. See, you get the answer 1.12. And they want the nearest integer. Uh, they want the answer to be, if you see this, we want the first place, second place, third place, fourth place, fifth place, and sixth place. And after 6, there is a 2, so it doesn't matter. So we can keep exactly this 6-digit number. So the equation now becomes, so the factor is 1.126092. So that's the B part. And now this equation now, final answer is y is 11 times 1.126092 raised to x. So what is x stands for? X is number of years since 2000, since 1998. So X stands for how many years passed since 1998, and Y is the population of gray wolf after X number of years. How many? It could be maybe in 1 year, 2 years, 3 years, 4 years, 5 years, 6 years, like that, and you get the output. There's one more question they're asking in the year 2020. So round the values in the model to 6 place in the population in the year 2020. So, that's what we did already. Yeah. That's it. They are not asking you any more questions. But if they had to ask another question, what about in the year 2040? So what would you do is you write 2040, you subtract 1998, and you will get this is 2, and you get 40 for 52 years. So you have to put the 52 in the calculator here, change, and you get the answer. The question number 12 is about modeling a real world application. In 1990, the residential energy use in the US was responsible for 962 million metric tons of carbon dioxide emission. In the year 2002, in 2000, so let's do only this piece. What does this piece mean if we make a table here? So in the year, I can use X and Y. X is how many years? In the year 1990. So this is 1990 is like a 0 year. That's where it starts. It's like 0 year. How much metric ton was the carbon dioxide emission was 962. But then in the year 2000, that means 1990, 91, 92, 93, 94, 95, 96, 97, 98, and 99 and 2000. So this is 2000. The emission is given to you 192. So this is 182. That means how many years have passed from here to here? And you can see it is 2000 minus 1990 is 10 years. So this is 10. So you have 2 points here, and the 2 points is 0 is 962, and the other point is 10 years is 1182. So that means this point becomes your x1, y1, x2, y2. But the good news is because this is 0, our work becomes easier. So when you write this, y equals a times b raised to x. So what is the x stands for? number of years since 1990. So X is number of years since 1990. And what is the meaning of Y is the amount of carbon dioxide amount of carbon dioxide emission after after X number of years. X number of years. Okay, these are the good things. So you can also use amount. Sometimes they use amount this way. You can use A, and this also could be T number of years. So variable can change. I'll stick to this. And eventually, as I said, you could write amount of carbon dioxide after T years. See this way. This is also you can write B raised to T instead of this. But because you guys get confused, I'll stick to this. Now you have because the first one in the beginning, this is 0. So by default, this answer is 962. The A is 2. So this is your A times. Now we need to know what is this. So for the second part, we'll pick this point. So Y is this 1182 equals 962 times B raised to 10. So then divide by, so solve for, so both sides divide by 962 and 962. Okay. So this crosses out. What are you left is B raised to 10. So I'm going to write B raised to 10 equal 1182. And then directly, now that you know what you're supposed to, how do I get away with this 10? The right side stays the same and raised to the power 110. Even though if you forget, it is like this. We have A raised to N equals P. So this is like a formula. So that's what I use there. Using the calculator, put this in the calculator. I already showed you how to use this calculator, and you get answer as 1.0208. And then, so the equation, this equation now will reduce to, instead of this, we have Y is, in the beginning it was 962 times, and the growth factor, this is the growth factor is 1.0208 raised to X. But then there is one more question is asked, what about 2050? Now 2050, you have to subtract and see how many years since 1990. So you can see if I do this little math, that's 60 years. That means when X is 60, let's plug this in, X equals 60 here. So your equation becomes equals Y equals 962 and put raised to the power, that's 60. Okay. So if you put this on the calculator, let's see, if I put this on the calculator, use clear everything and go to second is, okay, clear. And we want to put 962, so 962 times, open this, and 1.0208, close it, go up, put 60, and you get the answer. So simple. So you get 3. Oh, I think I messed up there. So go backspace, enter. So it is 962, and this is, yeah, correct. You got the answer. So round it to the nearest. Did they say what will be the emission growth in 2050? So we'll round it to your answer is already there. So it's 3308.37. So I'm going to use this, and the answer is 3308.4. So I'm going to use one place decimal. Even that they did not say it one place decimal, says continue the same way. What will be the emission in the year? So I'll just round it to one place and you're done. And I hope making sense there. Uh, Now, question is, is there a shortcut? Many will say, is there a shortcut? So those of you who understood, I'm going to show you a shortcut here. If you have a point 0 and something like a, and another point is given maybe x2, y2, the shortcut trick is you already know a because they will give you, and you want to know b. That b is always y2 divided by this a, see like this, and raised to 1 over whatever that they give you, this number, like from here to here, yeah. So this one. So it's like how many years? So this will be like your x2 actually. So in this case, it will be your x2 here. You can directly also get, but I don't want you to get confused with this. Let's stick to our regular problems. Question number 13. The population in the city in the year 2020 is given to you as this is 2020. That's in the beginning, right? It's 0. The population given 200,000. So I'm just writing 200. Basically means in thousand. So I'm just using 200 and has been growing. So now these are each year it is growing. Each year it's growing by 2.7%. What is 2.7% means? Divided by 100, it is 0.027. So the growth factor, this is the equation is y is a times b raised to x. So the a is the initial population, which is 200. So y is 200. All you need to know is the growth factor, the b part. And how do you find this b? So this B is always, it's like 1 plus R, it's like how much percent increase. So this B is 1 plus 0.027. And if you add, you get 1.027. And that goes right here, 1.027 raised to x. See? So you get a exponential model, but they want to know what about in the 2030? So 2030 will be like, or I can break this into maybe see like this. I'm just making my own. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 10. This is 2030. So in the year 2030 basically means it is from year to year is 10 years. Okay. The question is how much is the population? So all you do is when X is 10 years, how did you get 10 years? 2030 minus 2000. This 20, if you subtract, you get 10. This is what you plug in here. And you write 200, 1.027 raised to 10. Use the calculator. Now you know how to use the calculator and you should get 261.05 in thousands. So if we assume the growth continue at the same rate, estimate that the population will be, so the population will be so many thousands. And then if you want to really write 1,000, basically means it is 261.05 multiplied by 1,000, and you get actual population 261. And this decimal moves 3 places, 050. See, so it's almost like 261,050. Does that make sense? I'm tired, but still want to do. So question number 14 is, according to the New York Times, 7-day average for a new number of new cases of COVID on March 2, it was 9. Now, what does this basically mean? We can make a table like this just to get an idea of it. 7-day average basically means uh, so March 2nd. So this is March 2nd. That means we call it 0 day. So the number of COVID cases. So X is number of days, number of days uh, since March 2. Okay, and this is Y is number of COVID cases, number of COVID cases. So when it is on March 2nd, it was 9. And 1 week later, it means this is like 1, 2, 3, 4, 5, 6, and this is 1 week later. It means 7 days. From here to here is 2 plus 7. This is because 1 week is 7 days, so this will be 9. So on the ninth day, from here to here, so it is like 9 here. So it means 1, 2, 3, 4, 5, 6, and 7. So this is 7, sorry. So 7 days. This is 7. Maybe this is March 9, but for me, how many days from this day? So 0 to 7. See? So then the it is given to you a week later. A week later is 92. So this is 92. So the 2 points that you have is 0 and 9. And the other point is 7 is 92. So all you're supposed to do is this is your x1, y1. This is your x2, y2. So the equation is y equals a times b raised to x. Because this is 0, this itself, this easy. So the equation is y is 9 times b raised to x. Now you plug in the second one, that is, this is x, this is y. 92 equals a is 9 times b we don't know, and this is after 7 days, right? So divide by 9, you get this crosses out, and you get, let me put this directly here. So b raised to 7 is 92 divided by 9. And now you have to get away with this. So if you want, I'm writing the step one more time to those who get how it works. It's like both are raised to the power 1 over 7, 1 over 7. So this 7, 7 cross out. And you put this in the calculator. Okay. Just to save time. So this is what you plug in the see, I already put it. You can check. I already posted here. I enter. I want to go back this one, and I want to enter. So this is what I already done the typing. So you can do this 92 divided by 9. As I said, you could do directly also. You don't have to use that. Uh, you don't have to you use parenthesis. Yeah, parenthesis has to be done 92. You can do directly divide by 9, close it, and then go up and also do direct 1 divided by 7. And you can get the answer. See, so it is 1.398, whatever that is. So this is b equals 1.393865, 6 places. And the equation becomes y is a. A is this A, which is 9 in the beginning, that was it. And then 1.393865 raised to the power x, and you're done. But they're asking you, what about after 7 new cases after 5 weeks? See, question is, what about after 5 weeks? Now, when you talk about 5 weeks, basically means each week has got 7 days. So multiply by 7, that you get 35 days. So your x becomes 35. You plug in here. So you get y equals 9 times and put 35. And you get the answer. If you go to the calculator, I can go backspace and enter that one more time. Sorry, 9 times. So it is 9 times 1.393865, go up, put, input your number 35. Can you get the answer? See? So you get 1,004,000. So you can just write that answer directly there, and you get 1,004,540.538. So that's the population. I hope I'm making sense because I'm okay. So now you guys got used to this is about bacteria population, and it talks about in the beginning the bacteria starts with 300, right? So when you talk about the equation, this the main is the x. I mean the a part is 3. This is the in the beginning it was 300. But then we need to know what is that B, right? So we use that after 4 hours, because the second point is 4. The first point is 0 was 300. And the second point 4 is, it is 500. So this is that x2, y2. So in this equation, you plug in this y and this x, you get 500 equals 300 times b raised to 4. See? Now divide by 300. We can cross out this 20, this 300, and we get b raised to 4 is 5 by 3. All you do is just now come b equals this 5 raised to 3. You just have to raise to the power, because here it is 4 over 1. The other side become 1 over 4. Put this on the calculator, and I think you should get 1.36. Check, please. 36. 136, 1.136219. So this is the B part. So plug it here and you get the exponential model y is 300 times a 1.136219 raised to x, right? And you're done. Now next is they ask you what about 24 hours? So you have to put x equals 24, and you just put this on the in the equation, the model, and put raised to 24, and the calculator will do the work, and you should get 6429.99. I hope that makes sense. Let's go to another. Question number 16. A population of a small town. They gave you the exponential model. Look, this is given where T stands for how many years since 2010. It means in the year 2010, the population, that means 0 year, it was, this is what it was, 45,000. And they use instead of x is t and instead of y it is p. This is x and this is y, almost the same thing, but it's good to use these variables. What is t stands for? Number of years since 2010. Now the question is, what was the population in the 2010? And we got the answer, that's the population. Is the population increasing or decreasing? So how do we know whether it is increasing, decreasing? You can see the b, when you compare with that y equals a b raised to x, the b is 1.035. You can see it is greater than 1. And which is actually, I can write it as 1 plus 0.035, which is also, it is 1 plus 35 divided by 100, which is 35%. See? So that means this is the r. So this is that B, when you write B is equal to 1 plus R, which is percent increase, the R is 35 over 100, which is 35%. So the population is growing 35%. So there's a percentage increase. This is the growth factor. Hope that makes sense. Okay, this one is a little slightly confusing. Suppose you have in a ball 500. So this is a ball, and these are all skittles, which are, how many are there? 500. So this is like A equals 500. And each day you eat 1/4. So every day you want to finish 1/4. And what is 1/4 is 0.25. See? So that means if if this was the in the beginning, okay, and the next day, in one day, the next day the bowl will have one fourth is you already finished one fourth, right? So how much stays inside will be how much stays inside? Okay, so that means it is decreasing. So what is that? Uh, how much? What is that growth decay factor? Decreasing mean what is that B here? So one fourth basically means one fourth you finish, right? One fourth is 0.25. That means it is 25% you are eating. So how much is remaining? So the remaining here is 75% because you are finishing 25% you eat. So from 100%, if you subtract 25%, you get 75%. And 75% means 0.75. That means each time you multiply. So how much is remaining here is you each time, if this was 500, this will be 500 times 0.75. So you're multiplying a factor B, which is a decay factor, which is 0.75. So the equation becomes y equals is a b raised to x. But so the number of skittles remain. This is how much skittles remaining. You had 500 in the beginning, but this one is now 0.75, and which is raised to x. The number x stands for the number of days. Number of days. So the understanding piece is you are eating 1.2. That means how much percent decrease. So that's the understanding here. What percent is decrease? If you get confused with this, I can show another different way. So one, so so when you say one fourth is already eaten up, it means it is. Remember, it is 0.25, right? So now you want to know that B is actually 1 minus R here. So that is B is 1 minus percent in decrease. So this is percent decrease. So 25% decrease means you have to subtract 0.25. And when you subtract this, you get 0.75. And that's what goes here. So this time we are using first time, this is a decay factor here. This is decay factor. So I hope I'm making sense. And because it's asking you T, you could change this problem to 500 times 0.75 raised to T. That's all it means. So I hope I'm making sense to you. Oh, that was the last problem. I didn't even realize. And we are done. Let me check. Oh, that's it. I thought there was more. Okay, thank you for very much for listening. I hope I make sense. I know not everything that I'm showing is not perfectly. I'm just talking to myself. And please, I want you to really master this exponential uh, equation, or I call it exponential function. How each piece, what does this mean? What does this mean? Already done so many problems. And see you for the PIMA homework of everybody should get 10 out of 10. Okay? So get ready for Thursday test, exam 2. So exam 2 will be based on what we learned last week.